A Nephilim spider joining the monsoon banquet. She's caught a tiger butterfly. And he is utterly toxic. Butterfly predators.
System error. Shutting down.
Walk, don't run. Use the handrails. Walk, don't run. Use the handrails.
Neon Temple simulation reboot in progress. Live stream initiated. Stabilizing environment.
guess. No. 1, 2, 3, 4, 5, 6. Okay, there you go. We're back. So what I was saying, I was telling you guys about what's happening in the next couple weeks. We have our own Binary Badger. He will be giving us his cool little OSINT talk about how he used to chase some celebrities down and figure some stuff out through that. Then short round on Hack the Box Night. I was saying it earlier. You guys didn't hear me, so I'll say it again. It will be the first one that we do in person on a guild night. So come out, have fun, conquer a box, maybe a Sherlock. I don't know what his plan is yet. We'll find out soon, though. I'm sure it'll be fun and you'll learn something. From there, I think we have, our first social night after that happening. But this will be a kind of a good chance for you to just kind of come, hang out, meet the crew, talk about whatever you want to talk about. Work on some pet projects. Who knows, maybe somebody will pick up the guild lab and work on that a bit. But I think that is enough about what's coming up. Did I miss anything? Anything we need to mention? Anybody have a shout out? Nope, cool. So with that, my dear friend here, Tyler, is going to walk us through some awesome detection engineering stuff tonight. I'm sure you guys are going to like it. And without further ado, I will stop talking. Tyler, it's all you.
Sweet. Yeah. Hi, everybody. Thanks, Trey, for the invite to come out tonight, I guess, remotely. Thanks, everybody, for showing up. Okay, so today we'll be talking about Sigma rules, and we'll be translating those Sigma rules into some actionable detections that we'll be doing on the hands-on portion. I know that Trey had dropped kind of what our lab manual is going to be on, but we'll get to that here kind of towards the end. I don't have a ton of slides, so I'm hoping to talk for maybe 20, 30 minutes, probably 30 minutes or so, and then get onto the hands-on portion of it. Out of everybody here, does everyone have any experience with Sigma or utilized it or anything? Yeah, I see you back there, Peacock. Yeah, thanks. If not, no big deal. This is kind of at really a beginner level. We're not going to go over any like really crazy pieces. We'll like barely touch on some correlations and things like that. So it should be very beginner friendly. Sigma has kind of been my fascination for the last couple of months, really, and it's really powerful and awesome. I love to talk about it. So without that, I guess we will get started. If anybody has questions at any time, like Trey said, feel free to raise your hand or, grab the mic or, whatever it is, feel free to interrupt whenever. One thing with this is before we get into the actual hands-on portion and doing Sigma stuff, there is a lot of kind of talking around it. And then kind of towards the end, we'll show a rule, show the detections, talk about logic, and then jump in the labs. I think that this really, you benefit a lot more from the lab work and from doing it than just kind of looking at what the rules look like or how it's done. So with that, give me one second to fix my screen real quick. All right. So let's get started. So hello again, everybody. My name is Tyler Casey, and we will be going over some practical detections and threat hunting utilizing Sigma. So again, this is me. I'm the lead detection engineer and the deputy of Scythe Labs. I have about 10, 12 years of experience doing DCO, which is defensive cyber operations. Currently, I run the blue or the defensive side of our PTEs, our purple team engagements, and do a lot of the threat emulations. Before I came over to Scythe, I was on a CPT, which is a cyber protection team, which is basically a targeted threat hunting team in the Marine Corps. So before I came to Scythe, I was in the Marine Corps and then a federal civilian on the CPT. And before that, I was a data Marine, so like servers and networking and pieces like that. So kind of been in the field for a little bit. I live in St. Louis, but I will or should be down for B-Sides Tampa down there in May. So hopefully, if I haven't met you guys, we'll be able to connect them. All right, so kind of jumping into it, we're going to go over Sigma, kind of what it is, why do we care, a little bit of the background. I'm not going to go on a whole soapbox about it like I normally do. I'll just kind of rush through that. Then we'll get into Rules 101, which is just going to be reading, creating, standardizing some of the rules. We're going to talk about some of the, some of the fields that you need to utilize, kind of some of the logical piece of Sigma. behind it. Then we're going to translate it. Just like it says on there, it's pretty easy. It's only going to take a few seconds if a rule is done right. And then we're going to hop into the labs. So the labs are broken down into two different labs, I guess. So the first one is just some practical application. We'll get some skeleton Sigma rules that are missing some of the core detection pieces. So we'll kind of fill those out. I'll go over probably one or two of them together and then kind of leave it on you guys to fill the rest of them in. And then we're going to switch over to the Splunk Bots V1 dataset. This is a dataset. Bots is boss of the SOC. If you guys aren't familiar with it, it is a open source basically challenge that Splunk made. They started it in 2016. They still do it every year. The repos aren't publicly available anymore, but we're going to use that dataset to hunt through and kind of show how you can take Sigma rules, translate them, and then find real world adversarial activity. So with that, jumping into Sigma. Sigma is an open source structured format used for writing detections, and it's written in YAML. Sigma HQ is kind of the creator, I guess, for a better, for lack of a better word. They're essentially the creator and the maintainers of the Sigma project. And Sigma works basically just like we have this graphic here. We're going to take a rule that we're going to write. We're going to put it in a converter, and then from there you can deploy it to whatever SIEM or EDR you use, right? That's kind of the power of it. It's completely vendor agnostic, so you can use it for, we got Rapid7, Splunk, Elastic, basically any EDR or SIEM that has a query bar, you can translate your rule to that technology, and that way you don't have to rewrite it a bunch of times. So kind of my quick little 2-minute soapbox on it into why we made this workshop and why I'm kind of so passionate about Sigma is that people are not good at sharing detections, right? When people like analysts are hunting through something or trying to perform detection engineering of some sort, they write their rules in whatever SIEM or tool that they have, right? Because why wouldn't you write it like that? You write to what you have. And oftentimes people in this community can be pretty internal, right? A lot of them, we call them, the window walker or the hallway walkers. When you walk down the hallway at a big tech company, no one looks you in the eye. Nobody looks up. Everybody's just kind of following the wall. They have their finger on the wall, and that's what keeps them from running into anything. That's just kind of what the community is. Hopefully it's been changing, but the whole point of that is that people don't like to share what they've made, right? Or they have it in a way where you can only use it for Splunk, or you can only use it in Elastic, and it can be very difficult to translate that into a different SIEM, right? So using Sigma, it kind of flips that and makes it a lot easier and a lot more friendly to share what you're doing in your detections, right? So utilizing Sigma HQ's GitHub, you can have a central repo that all of the rules are housed and maintained in. If you can't, you can contribute your rules to the Sigma HQ project. If you're not allowed to share your rules for whatever reason, maybe you made them on company time, or you work in the government and these are classified, or the indicators are classified, something like that, that's fine. It's set up so that you can still host an internal repo of it. You can pull those rules down, host them internally, build it into your pipeline, and share them with the other defenders that you have, right? There's no sense in writing a rule that never leaves your notepad, never leaves your OneNote, never goes to anybody. It doesn't really help anyone, right? Which then kind of feeds into that standard format of that people write rules in different ways, right? Some people will have different log sources or think that different things are important. So by having a standard format that everybody can write in, it basically just gives you a language that everybody can read, right? It makes it easier to share. And then lastly, like I said a few times, that it's tool agnostic. It doesn't really care what tool you have. For the most part, as long as it has a search bar or a query bar, you can translate your rule to it. So over to Sigma HQ's GitHub, this you could obviously just go to the link down there at the bottom or Google Sigma HQ's GitHub. That's where they host all of the rules. They make it very easy to search through on there. Actually, just kind of switch over to it for a second, do Sigma HQ GitHub. So if you're looking for a specific rule, like maybe 7-zip or something like that, you just type it up there in the top right. And now you have all your 7-zip rules that are already made, right? Or maybe your detections, you want to look at lateral movement of some sort. I put the wrong thing in there. Just do lateral. If you want to look at lateral movement, you can just type it in, your lateral movement rules, or looking for even like T codes, 1059, something like that, right? So it's pretty easy to search through and find rules that people have already made. Another big one that people like is to search for CVE rules. So, you know, something like, I can't think of what the CVE number is for that SharePoint CVE that came out a couple weeks ago. But if your organization is affected by one of these CVEs, you can just go to this central repo, look up that CVE, and now you have a detection you can employ that other people have kind of tried and tested and put some work into. You don't have to recreate the wheel, right? That's kind of the whole point, right? Sharing in a way that everybody is able to use it. Another great resource on Sigma rules is detection.fyi. So this one pulls from multiple sources, not just Sigma HQ. It pulls from other public Sigma repos as well. We've got like the most recent ones up here, and the same thing, right? You can search 7-zip or T code or whatever it is. For some reason, like you guys can see, it's been extremely slow the last 2 weeks. Eventually, it will run my search. I don't know why. I don't know what's going on with it. But the rules will populate here for that as well. So again, just an easy way to kind of share and see. Not a Windows issue. At least I have internet today and it's not cut down, right? Like the other day. God, that was terrible. But yeah, the whole point of that, right? There's resources out there. It could be difficult to start making a detection. It can seem very cumbersome or very complicated. There's already rules out there, right? You can take those. If they don't fit your exact use case, you can move them, you can translate them, you can adjust them kind of to fit your environment, and that's exactly what it's for, right? So rules 101. I know that Ramses has seen this before, this little meme. So what I like about Sigma, again, is that you can take something that somebody else made and adjust it a little bit to fit in your environment or your specific use case, and can deploy it without really having to do anything else with it, right? Just something on the shelf you can grab and just start hunting. So for workshop, we're obviously going to get in the weeds quite a bit about Sigma rules and how to read them, how to write them, how to deploy them, all kinds of pieces like that. Before we get to that, though, like I said, we're going to kind of talk around it before we get kind of to the chunk of it. So I thought it would make more sense for you guys to see what a Sigma rule looks like before I kind of talk about all the fields and everything else. So this is a relatively simple Sigma rule. Again, just to give you kind of a frame of reference. So this rule here, if you focus on the detection section down there at the bottom, that's really where most of the meat is, right? That's where the actual logic and everything like that is actually located. And that's what we're looking for. That's what we're trying to trigger in our rule. So this rule here detects potential DLL files that are downloaded via the invoke web request commandlet in PowerShell. So again, if we look down to the detection section, we see that for our detection to hit, it has to contain either invoke web request or IWR, which is just an alias for that same PowerShell commandlet. And the command line must contain HTTP, out file, and .dll. The one, and then we have the condition down there at the bottom that just says selection. So those two detection logic pieces of the command line arguments, both the command line arguments containing invoke web request or IWR and containing all of HTTP, out file, and DLL, how you specify what you want those to do is with that condition. So you see right above the command line contains, it has selection there. You can have multiple different filters or selections essentially on there. So you can put more logic into it. You could put more ands or ors or nots or different pieces like that, which again, we'll see when we actually get to the lab portion of it, and see how it's all. Are there any questions so far? Yeah, we're going to explain all of this in much more detail.
We're good.
Thanks, sir. All right. So again, kind of taking a step back, right? The only way to eat an elephant is one bite at a time. So to take a step back before we get into the rules, you can't make a rule without indicators of some sort, right? If we look back at our previous slide, the indicators we have here are those command line arguments of someone running invoke web request, or an indicator of a command line argument containing .dll, right? Something like that. We need indicators to, excuse me, we need indicators to drive our rules and create good, valid Sigma rules. So there's 3 different indicators we're going to go over: CTI, experience, and logs. So the first one is CTI, which is cyber threat intelligence. This is probably this is a good, like almost a, when you're making proactive Sigma rules, right? When you're going to hunt for something before it happens in your environment, you're most likely going to rely on either indicators or experience, right? So your indicators, in this one, we have an example of a Lockbit ransomware indicators that came from a CISA advisory. This indicator here shows you that they take a registry key, that win logon registry key, and that they modify the values of auto admin logon, default username, default domain name, and default password. So how you could take a Sigma rule or how you could take this and turn it into a Sigma rule is you would have it set for looking for any of these registry modifications, right? You would have it look for if a registry key was modified inside of win logon, and if the values of auto admin logon, default username, et cetera, if those were changed or a modification to those values. So you can take this Sigma rule, translate it into something you can proactively look for, and then you can know kind of before an incident happens if this exists in your environment. Just a quick shout out, if you're not sure where to find CTI, this InfoSec Ninja's start.me page, which is this screenshot we have here, is a great resource. It's got all of these other resources we have mentioned on the slide are all in this start.me page. If you just look up InfoSec Ninja start.me, it's really fantastic. It's got tons of stuff in there. All right, kind of back to it. So the next indicator source that you could pull from is logs. To pull from your logs, something has to have already happened, right? So this is a great use case for running a purple team engagement or running some MITRE attack behaviors in your environment, kind of driving that offensive signal in your actual environment or your lab environment. If you can't run it, in real life, you can run something to trigger these logs and then create a Sigma rule from it. And now you have it stored so you don't have to recreate it, right? So in this instance, we have, what do we have here? We see that a network connection was detected, a network connection was created by PowerShell. That's probably something that is abnormal in your environment, right? That's something you would want to know when it happens. Attackers like to use PowerShell command line, terminals, things like that to live off the land and run things from that, because they don't have to bring that in. So if you see something like PowerShell or command line or something like that reaching out to the internet, it's probably something you want to create a rule for and be alerted on, right? So in this instance, we would take this rule, we would take this indicator source, we would have our rule set up to monitor for network connections with the parent image or image of PowerShell, right? So anything that PowerShell is doing, connecting out to the internet, we would want to make a rule about that. One of the things about Sigma that I do like, and I alluded to a little while ago, is that you could put different filters in there or different selection choices in there. So if someone connecting to the internet over PowerShell is common in your environment, that's fine. You can put in kind of known good or assumed good sites or users or computers, machines, anything like that, and you can exclude that from your search, right? So if you have a user, Tyler.Casey, that uses PowerShell scripts to connect to the internet to do, typical day job stuff, and your alerts are getting blown up because I'm always using PowerShell to connect to the internet, you could put an exclusion in your rule of if the user equals or contains Tyler.Casey to ignore it, right? And this will all make a little more sense when we get into the rules themselves. And then the last indicator, and maybe the best, I was going to say, I think most of the indicators that I make are built off logs or CTI, but a lot of them start just with things that I think are interesting or things that I think are bad, right? So probably the first Sigma rule I ever made was, had to deal with the threat vector of having embedded PowerShell inside of a productivity application like Word or PowerPoint, something like that, right? Or a PDF, something like that. So a user gets an email that has a PDF, they open it, it's got some kind of embedded PowerShell in it. Once they open it, PowerShell spawns and then does whatever PowerShell does, right? So that was just an idea that I had from talking to probably Trey, actually, of something that he does pretty often. I guess this is relying on his experience and not so much my experience. But you can make a rule proactive to actually seeing that in your environment, and then going back to the logs portion of then deploying that offensive signal or whatever it is, your purposing exercise, something like that, to then verify that your rule does work, that it will trigger when something like this happens. And as you do that, you can continue to build onto your rules, right? They don't have to be stagnant. You can always continually build on them, and you should revisit your rules. It's called regression testing. That's another talk, but it's called regression testing, where you continually go back every few months or any kind of cadence like that to make sure that your rule still triggers like you think it does, or see if there's any improvements that need to be made to it. Right, so like in this example of you have a Word doc or a PDF you get sent that has PowerShell in it, right? You have that, now you realize that, someone could send an Excel document or a spreadsheet or something like that. So then you can add to your Sigma rule, you can add to your detection rules to then pick up on some of these other pieces. Again, just growing with experience, with logs, with this CTI that you read or things that you have observed, kind of a combination of all of these things, right? All right. Outside of the logs, the indicators, we know where we can kind of pull indicators from. So we get into the actual rule creation itself. So before we get into the fun stuff of the detections, to talk about some of the other fields that Sigma has, right? So if you remember on one of those first couple slides, it's shown, it's got a title, it's got IDs, status, description, references, author, and then there's some more on the next slide. All these are pretty self-explanatory. The only real ones I'd really hit on this is the status and description. Your status, you want it to be experimental until you test it. Don't put it as stable or stable or tested or anything like that until you actually run through. It has months of testing, months of other people using it. Leave it at experimental. And then the description, just start description with the word detects. That's how they like it. That's the format. Nothing really crazy there, right? And have your description be as descriptive as possible. I always say, like, when I write a rule or I write a report or really write anything, I don't want people coming back to me with questions that I should have already answered, right? So have your description and your references be as descriptive as possible so people can kind of fill in the context on their own and without having to reach back out to you. And then a couple more fields, the date, false positives, and level, all pretty self-explanatory. Your level is going to be defined as either info, low, medium, high, or critical. You think of your informational low and medium to be suspicious activity or like policy violations of some sort, maybe like some potential unwanted application or software, something like that. Or it could also be ones, it's okay with your informational low and mediums to have some false positives in there. That's fine. But if you do get anything that you get from this will still need to be investigated, right? So it's okay if you get some false positives on there, but with your lows, mediums, and informational, it shouldn't be like a 5-alarm fire, right? It should be like, okay, it's added to the queue. We'll take a look at it. Probably nothing, but you still want to be aware of it and know what's going on. Your high and criticals, those should be your high fidelity alerts that should trigger a dedicated alert, right? So your high and your critical alerts should have very low false positives and should immediately spawn an investigation. Something that could be a critical alert, probably, those CVE rules, right? If the Sigma rule for the SharePoint CVE is triggered, that's probably something that should require an immediate investigation. Low false positives, right? Your hair is on fire, something bad is happening. So just kind of be diligent with what level you give it, because based off the level you have should kind of warrant some type of response, right? And then your false positives, it's important just to put those in there so people know kind of what to expect. And if they do get a false positive, they can kind of suss it out more more quickly to exactly what happened, right? So some examples of that could be like an administrator uses PowerShell for server maintenance or updates or, whatever they use it for, or some end user installs software, something like that, or something new was installed, something like that. Or if you're not sure what could be a false positive, you can put unknown. If this rule is so airtight that there's nothing that should trigger it unless it really happens, then you can put unknown in there, and that's totally fine too. All right, and then the fields we have here that have asterisks on it are the ones that are going to require a little more nuance, and they get their own little dedicated slide. So to get into the tag portion of it, the most common tags that we see are attack, car, CVE, and TLP. First up is attack, which is the MITRE ATT&CK framework, right? Everybody is familiar with that, I assume, or has heard of it at least. Yeah, seeing head nods, everybody knows it, right? Most people only see it or know of it for their tactics and techniques. They do cover groups and software as well, which is pretty interesting. So like in this example, we have attack.discovery is the tactic, attack.t1018 is the technique or group, G0016, and software S0521. So just a quick way you could take those, go over to MITRE ATT&CK and look up what software that is, what group that is, what tactic ID that is, and things like that. So kind of just the story from the attack piece is G16 is APT 29, right? So APT 29 is conducting discovery, which is their tactic, utilizing the remote system discovery technique, which is T1018 via Bloodhound, which is S0521. So just from those 4 attack tags, you can kind of make out a little bit of a story into what's happening, right? You know who the threat actor is, you know what they're doing, you know what software they're utilizing, different pieces like that. Just provides more context, tells a little more of a story. Ideally, people get less questions back to you, right? You want to be able to answer all of them in the rule without having too many people come back and ask you more stuff about it. But that's just me. That's how I feel. Next up is CAR. I think definitely less well-known, maybe the least well-known of all of the tags on here. CAR is the Cyber Analytic Repository. They essentially tell a story of what happens, and I'll show you an example here in a second. This one we have CAR 2021-05005. This tag, this analytic tag is linked to a story that shows us that Bits admin is utilized to download a file. So in this hypothetical kind of situation, maybe we'll assume that the file they download is Bloodhound, right? They download a Bloodhound executable. Now the CAR and the attack tags, again, telling more of a story. I'll go over to one of the CAR examples. So you can just go to carmitre.org, and then I like analytics by technique. I'll just click on one of these top ones. So again, in layman's terms, kind of just giving you information on what's happening, right? So a little paragraph up here, attack to MITRE, some defend techniques on there that'll have some detection logic and pieces like that in there. Data models if you use Splunk, and then into the actual detection pieces itself. So utilizing pseudocode here, just kind of like if the file equals this, output LSAS dump, that'll trigger the rule. A lot of these, though, will actually give you different SEAM or different languages searches already in there. So again, another way to kind of give you a leg up, and you don't have to go in and create all of these from scratch. They already exist. People are already doing it, just like we're going to do it here in a little bit. Use the resources that are available. It makes it a lot faster to determine what's normal, what's bad. There's a ton of research already done. And then here is actually what you can do. This is from the Mordor project, which is a almost like an attack validation data set that they have. So they recorded, I believe it's APT 23 and APT 30 something. They recorded that adversarial activity in the Mordor project. So you can load this into Splunk, and then these rules that you have up here will trigger on this activity. It's just another way to kind of verify that your rules are working. I would definitely check that out if you guys are not familiar with it. So that's the CAR, the Cyber Analytic Repository, also hosted by MITRE. And then next up is CVEs, common vulnerability and exposures, right? This is a list of vulnerabilities that affect operating systems, software, anything IT related. Your fridge probably has a CVE, right? Anything that has an IP address is probably listed on the CVE website in some way. So here we have CVE 2019-15701. This is a vulnerability in Bloodhound that allows you to run different commands through it that it's not supposed to be able to run, right? So again, a Bloodhound piece telling the story using the tags to tell the story. And then the last one is TLP, which is your traffic light protocol. This just tells you what you're allowed to tell people, right? So green, clear is you can send it to anyone. Green, keep it in the community. Community is typically defined as cyber security, which is, essentially clear, right? Green, clear, you can basically feel free to share it. Amber is limited disclosure on a need to know, and a red is intended recipients only. Unless your organization ingests some kind of paid for Sigma rules, or you work in the government, you deal with some classified information. Pretty much everything you see on the internet should be either green or clear, right? If you see green or clear, that means you can share it with anybody. And then the last thing on tags is you don't have to use all of the tags, right? 95% of the time, it's just the attack tags, right? It's just the technique and tactic that groups are using. So you don't have to don't feel a need to do all of these things. You can just kind of do what's applicable. And I would say at the minimum, attack tags, right? And then definitely your biggest resource is this link that I have on there. Sigma does a great job with their documentation of the different specifications, which we'll show here in a little bit too, but they do a great job of giving you references to point back to and able to write your rule in a standard format, right? You don't need to memorize all this. And then next up is log sources. Now we're getting more into the actual detection piece of it. Your log sources are going to kind of give your rules a system of classification of sorts, right? So it's going to tell you, like, is this a network connection? Is this a process creation? It's going to kind of tip you off to where the source and source type and event codes of your rule, what they're going to be, right? So your product is typically something like an operating system, an appliance, or a tool. So your product could be like Windows, Mac OS, Zeek, AWS, something like that. Your category, I think of it as an action that's occurring, right? So your category is going to be kind of what is happening. Is a process being created? Is a network connection being stood up? Is a file being modified? Something like that, right? It's the action that is happening. And again, all of these are at this taxonomy link down there at the bottom. There is a lot more than just the 9 that I have up here. And then the last, probably most common one is the service, which could be a literal service like syslog or something like that, or a service that is provided like CloudTrail, or it could be a protocol like HTTP or DNS. Excuse me. Most often, again, probably product and category is the most often that I see when we get to the lab in a little bit. That'll be pretty much the main ones that we'll do. It'll be, product will be Windows, and category is going to be whatever is happening. Another one, the last one before we get into the detection itself is the file name. This is kind of a soft convention, but generally how those are written is going to be your category or your service, your product, and then the action. So a process created on Windows, 7-zip dumping files, right? Just kind of a standard way to write the file names, just like anything else. Just thought it deserved a call out because they do have a specification in there. Again, refer to the documentation. There's a ton of them on there. I think if you guys go and check it out, there is a lot of information on there. All right, so to the detection piece itself. Went over kind of all not the boring stuff because it is important, but kind of into the meat of it now. We went over the fields, went over the standards and the file names. So this is what it all looks like together. So this rule is looking for 7-zip that is compressing a file with a password. So this rule is tagged with the tag T1560001, which is archive collected data via utility, the utility being 7-zip. And then the log source that we see here is that it is looking for 7-zip process creation on a Windows machine. So we see there, so we know now that we're looking at our Windows logs or sysmon logs probably, and we're looking for process creation, which in sysmon is event code 1, and in security logs is 4688. So it kind of specifies again on what kind of honing in on what you're looking for before we even get to the detection piece itself. That's why the log source is important. Log source doesn't always translate super great because people don't always follow a standard of what their event codes should, or excuse me, not event codes should be, but what their field names are called, or their index, or their sources, or things like that. So it doesn't always translate great when you do an automated conversion. But as a defender, you should know that if you have a Windows process creation, you should know where that data exists, right? Security log, sysmon log, EDR logs, things like that. And then over on the right, we see the actual detection piece itself. So our detection is looking for matches on 7-zip and command line parameters. And each of those have their own selection filter. So kind of how I was showing in the beginning, it just had the one selection, and that was it. You can break down multiple different filters. Most commonly, it's just selection underscore whatever it is, right? So that top one is looking for some information on the image. The second one is for the password command line actions. And then the third one is the actual selection action also in those command line arguments. And then our condition is looking for all of those different filters to be true. And we'll break this down kind of line by line on the next slide. Then we see that the false positives for this are legitimate activity, right? There are people that use 7-zip command line arguments to archive files. I do. I think it's probably not very common. Most people just right-click, go to 7-zip, which would be a parent image of Explorer. But most people aren't going to do that. So I think this is probably a pretty decent rule for identifying 7-zip command line arguments. Something pretty abnormal. You see that the level is a medium, not quite a high, because it does happen in environments, especially with administrators. But definitely something that you would want to take a look at. And then, so a little more on the detection piece itself. We'll break it down kind of line by line, like I said, because the most important piece of this is obviously the detection logic, right? That's where the meat of it is. That's where we really kind of get the bang for our buck out of it. So essentially how the detection logic is going to work, it's the same way that seams work, right? You're going to match a field to a value, and then you're going to give it a logical condition for what you want to match. Does everyone know what I mean when I say like a field to a value, like description equals 7-zip or command line equals -p?
Yes.
So they were tracking for.
Yeah, we did one a couple weeks ago. People were like, I don't understand that. All right. Yeah, so the first one, so we have a couple different filters that we talked about on the last slide of that selection image, selection password, and selection action. So our condition, again, is going to look for a match on all of these things. So the first one up is the selection image, which is looking for the description, image, or original file name to be some form of 7-zip, right? At least one of these has to match for us to meet the first condition. So we'll imagine we get a hit on the image being 7z.exe, right? So that's great. The next one up is that we're looking at selection password. And what that is looking for is that the command line field, right, the command line string that contains -p. This has to be a match for us to meet the condition as well. We get another hit on that. So now we have selection image and selection password are hit, right? And then the last one up is selection action, which is going to be looking for a command line string that contains either an A or a U with spaces in between them. At least one of these have to match to meet the condition. So in our instance, in our logs, it does have an A with a space on either side. So that means that all of our conditions were met and that this rule will trigger, right? One piece that I didn't really hit on, but I do on the last slide, is I talked about like contains, ends with, contains, things like that. You can see it has like command line pipe and then what's called a modifier. So the modifier is what gives it, again, a little more logic to it. So what contains is going to do is it'll put asterisks around either side, which will give it a wild card, right? So it doesn't matter what's before or after it. It's going to put asterisks around it. So if they have, like for command line contains the -p, they could use -p, they could use dash password, dash pass, maybe something like that. So because it has contains, it'll hit on either of those. And then we have ends with for the image. The reason it has that is ends with will put the ends with modifier will put an asterisk in the beginning. So that way you don't have to put out the whole kind of path of where it would exist, right? So the image ends with 7Z, 7ZR, 7ZA. So regardless of if it's in downloads or program files or wherever else, it'll put that asterisk, that wildcard in the front of it and match on that. Can anyone tell me why the command line arguments at the bottom for selection action have a space on either side of it?
I'm just looking. That's the one at the very bottom. Condition course.
So the selection action uses that uses the contained or contains modifier. So if you don't have a space on either side, any word that has the letter A or U in it will match this, right? So putting the space on either side is really kind of critical, because if you don't do that, your selection action is going to hit on probably like most English words, right? A lot of words have a A or a U in it, right? So that's what the space is on there for. So when it puts the asterisk, puts the wildcards on it, it doesn't just involve everything. All right, and so now we'll translate the rule. So we're going to take the rule that we just had, and translating it is pretty much the easiest piece of the whole thing. So you take your rule, you go to sigconverter.io, or you run Sigma CLI on the command line argument, or use uncoder, or some other kind of tool like that. Sigconverter is what I recommend. You paste your rule on the left. You select your backend, which in our instance is going to be Splunk. But if you have Kibana, Elastic, ArcSight, whatever it is, you can just change it to that, and then it'll translate your rule on the right. So what you can do now is take your rule on the right, go over to Splunk, paste your rule in there, and see if you got any hits. So in this instance, we have that 7-zip process, which we did get a hit on. You noticed our query that we're going to run on the right just has the fields that are here, right? It's got description, image, original file name, command line. It does not have the index or the source type in there. You can kind of modify that when you're doing the conversion. You can change the format or the pipelines, which will then kind of include that. But so it's not always super reliable, doesn't always work, because people have their seams or their tools set up in different ways. So most often, in my experience, you're going to have to put that in on your own. The point of the index and the source type is because it makes it translate faster, right? If you're looking for this activity over a huge time span, like a year, or that's too big. It'll never work over a year. But if you're trying to run this over a week or a month or something like that, it's going to take a very, very long time. Depending on how large your organization is, it might just time out. You might never get anything back. So being as specific as possible and just including your indexes and your source types, host names, different things like that is really valuable for just kind of hunting through the seam in general. This Sigma rule doesn't know what your indexes are called. Or they might not know what your sources are called. So that, again, kind of going to be on you to kind of suss that out. But this one, so we took that 7-zip rule, threw it in SigConverter, translated it, threw it in Splunk, and we got a hit, we can see that our attacker person was able to use 7zip.exe with the password of Rhino Forever 1 at bang to archive the recon.txt into exfil.7zip, right? So pretty easy. If you know that that's something that you're going to hunt for, you're going to look for in your environment, you can, again, either go to Sigma HQ, go to detection.fyi or whatever your different, whatever your internal repo is, and find a rule that somebody already made. Any questions on that kind of quick rule translation going in Splunk?
Anybody? Questions, comments on translation? Be clear? Anybody lost?
Yeah.
Sounds like we're good on this side.
We said the thing that I like most about it is that it's pretty straightforward, right? It's nothing super crazy going on. There's always more complicated things that you can do with it, but for this, we're just going to keep it pretty simple. So with that, it's lab time. Trying to get through that really as quickly as I could. So over to our labs, if you go over to that GitHub site, it'll take you to our lab information here. What's up?
Nothing, Tyler. We were just saying that if anyone needs it, it's in our Discord.
Oh, all right. Thank you. Just heard some. Yeah.
So if anyone online is listening, then if you need the GitHub, it is in the event discussion.
Thanks, sir. Yeah. So with that, the main portion we'll be focusing on here is just the labs itself. Everything else is kind of hosts the rules and has some other information. So the first one we're going to run through, so I'll talk about them a little bit. Again, is this Sigma practical application. So we have some skeleton rules. I think we have 5 skeleton rules in here that'll go over writing a Sigma rule for who am I believe it's a net user, encoded PowerShell execution, download abuse, and a scheduled task creation. Up here at the top, again, this is something you're definitely going to want to utilize for this, is the actual specifications for the log sources, the field modifiers, and the condition logic here. If you go to the specification to taxonomy. So inside of the Sigma appendix taxonomy is where it's going to list out all of the log sources and the categories and things like that. All of the rules we're going to make today are going to be based or all the rules we're going to make for this practical piece of it are going to be Windows rules. So we'll go just to Windows folder. And then here it breaks down really in a lot more detail what your product and log source is going to be and how that is going to translate in your rule, right? So if you have Windows process creation, event ID 1, if you're looking in Sysmon, different pieces like that. So this is going to be critical to kind of figuring out the log source piece of it. And then the detection piece of it here. We have some hints up here at the top into what fields are going to match the values, right? So I'll kind of go over this one with you guys. We'll kind of walk through this one. It's probably not the best way to do it, but I think for this example, this is probably the easiest way, is to take your, oh, sorry, I didn't realize that screen wasn't sharing. 1 second. Is to take that skeleton rule that we have here. So the first one we're going to do, again, is that who am I execution. Go ahead and copy that, toss it into SigConverter. So if you go to sigconverter.io and select your target as Splunk, and then the easiest way I think to do it in this environment is to just kind of do it live. So your category, actually let me share 2 screens and put these side by side.
Can you zoom in a bit as well, Tyler?
Yeah, no problem.
Thank you.
One second. I shared the wrong screen. Yeah, there we go. Okay. So again, sigconverter.io over here on the right. I'm going to do our targeted Splunk. That's what we're gonna be using in our lab environment in a little bit. And then the format in the pipeline we can leave. You guys can fool around with that as much as you like. We'll just copy and paste the skeleton rule over here, and then kind of using the hints, we'll kind of go through what makes this rule, right? So we'll go back to the taxonomy to Windows folder. So we know it's going to be Windows. So our product is going to be Windows over here. And then the category. So we're looking for who am I command execution. So what do you guys think our category is going to be out of the log sources that we have over here on the left?
User enumeration.
User enumeration. Okay, I can see that one, but it's a little further back. It has to fit one of the categories that it has over here. So just kind of going down. Well, go from network connection up. If we're looking for an adversary running who am I on a box, is that going to be a network connection? No. Is that going to be a file change? No. It can be a process creation, right? Because you're going to run PowerShell or run command line, which is going to spawn a process, which is then going to run who am I. So our category is going to be process creation. So anything when you're looking for command line arguments, more often than not, I'll say maybe even all the time, if you're looking for command line arguments, it's going to be process creation, because that process is being spawned. And then our selection, again, is going to be the blue one, is going to be our field, and the one on the right is going to be what we want our field to match, right? So if we're looking, we can use the hints over here as well. What field are we going to look in to try to identify this malicious activity? So some pretty common fields are like image, command line, computer name, anything you would see kind of in a standard log.
There's hints on the page. What was that? So he's saying command line.
Command line? Okay. Command line can be a good one for sure. So command line, and then what do we want the value of that field to be? So we're looking for who am I execution. What command line argument are they going to have to run?
I would say it has something to do with who am I, right?
I would say probably who am I is what we're looking for in the command line arguments. And so you can see that our rule down here is translated, right? So we're looking at the process on the Windows machine with the process creation of some sort with the command line argument of who am I. We can take it a step further as well, put some of those modifiers on there. So if you do the pipe, you do something like ends with. So if your command line arguments ends with who am I.exe is going to put that star up there in the front. Probably not what we're looking for. You do begins with, or no, starts.
Yeah, we had someone say starts with here.
Yeah, starts with. So that'll put it down there at the end. Not terrible, but typically for command line arguments, you're going to want to stick with contains, right? So that's going to put the wildcard on either side. And that way it's going to look, if there's anything in between it, it doesn't matter. One of the, we can do in this is get a little ahead of ourselves, but I'm going to jump in this one anyway. In our lab environment, we're going to get to here in a minute. 1 second to go to the site. The plan was to run a whole adversary emulation that covered all of these ones we're going to do in the practical application, but to be honest, I ran out of time, so I didn't. I did not. All of the ones in the second lab manual, the bots v1 walkthrough, you'll be able to actually do put the queries in Splunk. But let me just modify this real quick, and I'll go over how you guys need to do this in the other lab when we get to it here in a second. So I'm just going to set the dates because this is a huge data set. It's going to set the dates to when our activity is. And we'll just take this rule and we'll paste it in Splunk, see if we get any hits. It's taken very, very long time. It's got a lot of alerts, or excuse me, a lot of events and things like that in there. So we're going to speed it up a little bit and give it bots v1, and we'll give it event code equals 1, because we're looking at process creation. So if we look back at our description of the log source of the categories, you see event ID 1, or in our instance, it's going to be, I believe, event code 1. There. Run a search. Maybe it is event ID and not event code. I forget which one it is in here. Yeah. Oh, this is going. Also, while it's looking for those, might be too specific on it. While it's looking on those, you could also, so instead of the command line argument containing who am I, you have some other options. You could do the image of who am I. So because who am I is a binary, who am I.exe is a binary, it'll actually be the image or the process that's being created. So if you wanted to change the rule up a little bit, instead of looking at the command line arguments, you could look at the image and maybe ends with who am I.exe. So this this line, or this modifier that we have here, it's being so weird. Ran this just a little while ago. I'll just run like that. This selection image that ends with who am I is probably most common of what you see for images, because it's going to have that full command line path in there. So you'll have the slash in the front, so that way it doesn't care about then system32 or program files or temp, wherever it is. It'll put the wildcard over there on the front and then look for just an image that ends with who am I at the end of it. I don't know why this is giving me such a hard time. 1 second, let me try the other one. Star. Oh, hold on. I think I'm in the wrong. There we go. Sorry, but I don't know what happened. I don't know why it took so long. But in there, see that we do get some hits back, but there's not a ton of, like, it's pretty difficult to kind of parse through all of this when it's just these raw logs. If you're not familiar with Splunk or Seams, on the left, they'll have some of the interesting fields. You can click around in there if you want to see the image. Like this is what I was saying with the image of who am I. Your images are going to look like this, which is why most commonly you'll have your Sigma rules, your Sigma modifiers for image be ends with, because you're just concerned with this very, very end piece, right? You should be able to look at event codes. We see 7, 1, and 5, 1 being the process creation. And then see if we have, so if we do event code equals 1, and then do here is table out some of the things we think are interesting. So parent image, parent, command line. Another one in Splunk 2 or any kind of seams in general is you can pull out just the fields that you want to see. So when it comes to like process creation or things like that, most commonly this is what I'm looking for: the parent image, the parent command line, and just the typical command line of what's happening. So both of our searches both of our selections with the image ends with or with that command line contains will both trigger and return a value for this. So just to kind of go over it from the top, we have our title, who am I command line execution. The ID is just random, an experimental status because we haven't tested this, even though it's a very a very simple kind of rule. Our description of what's happening, to text execution of who am I commands. The MITRE attack reference is fine. Date, the tags, this is a discovery command looking for some user discovery, some user behaviors, and then into the juice of it of the log source detection and selections themselves. You want to refer, again, when you're kind of first beginning to do it, you want to refer to the taxonomy documentation. It's really going to give you a leg up and keep you from kind of guessing in between what you need to put in here, right? So your product is going to be Windows because we're looking inside of Windows logs, and your category is going to be process creation. If we were looking for like PowerShell reaching out to the internet or something like that, that would be a network connection. Or back to looking at that lockbit indicator we had shown on the slides a while ago. Looking back to that, if we were looking for those registry modifications, we would be looking either for the registry events, which are going to cover registry adds, deletes, sets, and renames or any kind of modifications. So based off what the action is that's occurring is how you're going to set your category. In this instance, they're going to run who am I, so that's going to be a process creation. And then to the actual detection piece itself, to think of, it's a lot easier to do it when you have like the logs. So if you go up. So like in this example, if this was a registry one, if this was a registry event on Windows, this would be value contains, and then we would change this to auto admin logon, and then this would be data is 1, right? Something like that. I did too many quotes. So to change this one up from before, right? This is when you're looking at the indicators at the log sources or at the CTI, it's a lot easier than when you're just kind of trying to do it. But the category of what's happening in here is that some kind of registry event is going on. It's happening on Windows, and the values that are being changed are auto admin logon to data 1. You even put a little more information in there because that's kind of broad to, registry key or whatever it is, and you have it set to registry key ends with win logon, right? So now this value, it's going to have the asterisk in the beginning. Actually, put a little slash on it, make it a little more precise. Get win logon over there, the value of auto admin logon, and then the data is 1. So you can see how this kind of maps across all the way across it, just matching fields to values, right? That's all that we're doing here. Excuse me. And then we'll do one more and then kind of leave you guys to go through some of these on your own for a little bit. With the 2 hours we had planned for this, I'd really only thought we would get through maybe most of the practical application piece. There's another one, just want to get into it so I don't forget later, of the utilizing Sigma rules that we've already made to kind of give you a guided hunt, also called a safari. That's not a made up term. That's really what it's called when you do a guided hunt, a guided threat hunt. So we have 2 different Splunk instances that are online. Again, I didn't have enough time to stand up my own and feed all the data into it. So we're using some that already exist, but it's utilizing that bots v1 data set. So you can go to this Splunk samsclass.info. This is on the workshop manual.md markdown file. You can go to this one. It's got the creds there, student 1, or you could go to bots.splunk.com. Here, you have to register for a Splunk account. So if you don't want to do that, just use the other one. And then what this scenario is going to do is walk you through a Poison Ivy APT attack that's built into the scenario itself. This is more of a white box kind of hunt because we already know everything that happens, where essentially I just kind of walk you guys through hunting for this different activity. We have the Sigma rules here. We have kind of what your example Splunk query should be after you translate it. It kind of walks through what it's doing, what you're seeing in different pieces like that. So the plan for that one is for you guys probably to kind of walk through that on your own. Should be very self-paced, so you can get through it. And if you have any questions, feel free to hit me up. Yeah, back to the practical application. I'll walk through this kind of network enumeration one, and then leave you guys to it, like I said. So let me refresh this. Sometimes SIG converter gets mad at you and you have to refresh the page. Okay. So in this one, we are looking for a detection of net user or net local group commands that are used to enumerate some accounts. So the hints here, there's also going to be a process creation event. The process of net or net one is going to be used. Another word for process is image. That is typically what you'll see inside of Seams, either image or image.process. And then it'll have the command line arguments of user or local groups. And because we have the process and the arguments in here, we're going to have our condition is going to be a little different than just selection, right? So our category, we kind of give it to you in our product. We know it's going to be a Windows box, right? And then our category, if we're looking for someone executing a net command, what's our category going to be? We're looking here in the log source.
Three
for a network connection. Close.
Net command or net connection?
Oh, net command. Okay.
Yes, looking for the net command. So using like net use, net groups, using that. So if we're looking for something being executed, it's going to be a process creation. So we're going to put the category for process creation. Then we'll get into the actual logic itself. So the process that we're looking for is what is the image going to be if they're running a net command? And then to you guys, if you scroll to the bottom, we got a little answer key in case you guys need a little hint. We are not on our own out here. We got some resources.
It's gonna be Windows.
Net.exe.
Net.exe. Yes, I heard it. So net.exe is what we're going to be looking for the process or for the image. So the field that we're going to use is going to be image over here. We're going to have ends with, because that's typically what we want our image to be, right? It's going to end with quotes. Why are you yelling at me, Sigma? All right, so selection process, we have that image ends with net. And then it also has in here that our image could end with net1.exe. So we'll do net and net1.exe, put some slashes on there. One call. It's not copyright. Hold on one second. Must be something wrong with the formatting on this one. That's okay. We don't care about the tags or anything on this one. We're just going to kind of go through making it. So the category, process creation, product, Windows, our selection process is going to be, again, the image, which is going to be ends with, because that's what most images are going to be. And then we'll give it net and net1.exe slashes. And then we have selection args, which is going to be, so then in the selection arguments, what we're going to be looking for is, so if we looked at the process, for the selection process is going to be the image, then the selection arguments is going to be the command line arguments, right? So we're looking right now at if an image of net was ran, what did that image then do, right? So in this, we're looking for if it ran, ran the command line contains. So they ran net, it spawned either net or net1, and then the command line arguments that we're looking for that they ran would either be user or, in this example, local group, right? So we're looking for if they ran net user, net local group, just some typical kind of discovery commands that they could have ran. And then our selection now has to change. We have two different filters in there. So our selection, one second, my screen just went a little weird. So then our condition, our selection is either going to be selection process and selection args. Exactly. Or you can do, I always mess this one up, all of selection underscore star. Either one. So you can specify all of them with the all of selection underscore star, which is going to take that piece, and then all of this is going to be a wildcard. Or you could do selection args and selection process. To some of the more logic piece to it, let's say we have the selection process and we don't care if it has the command line arguments of user or local group. Doesn't make any sense for what our example is, but just to show kind of how you can use the different logics to it, you can do and not selection.
I think you're muted.
Oh.
See your lips moving. We can't hear you.
Can you hear me now?
On Chris's end.
Oh.
You're lighting up green.
Can you hear me now? Hello, hello, hello. Hello. Ramses, can you hear me? I see your hand moving.
Can you just get muted or something? Where's the remote? Well, it's still.
He's going through the speaker. Yeah.
Oh, the speaker behind it?
No. Trey had it connected. It's going through the speaker.
From the laptop. Oh, maybe it lost Bluetooth.
The TV was making Tyler say double things, so Trey connected the audio to Bluetooth. So that if he stepped out, the Bluetooth speaker.
Something still connected to Bluetooth. Yeah, he's not muted. Oh yeah, that's a Discord version, so it's still connected.
Yo.
So that green.
Test 1 2. Test 1 2. Hot on the mic.
If he's got to get the speaker on there.
No, we heard the Discord notification. The speaker.
Tyler, I think it's your end.
No problem.
No, but you didn't really talk. First confirm.
It like, and it's not, doesn't say muted, but if his headset has a different mute, then it'll show like he won't show up, like the green box won't show up for him. Sometimes it does if it thinks if like it doesn't hear anything else and you're moving and it's like it's focusing on you because you're moving.
Say sometime.
Something.
There we go. Okay, there you go. There's
Test 1 2. Hot on the mic. DJ Jazzy Jeff.
John? Okay, stop. Say something else.
What do you want me to say? You said say something.
Everybody's jamming Bluetooth. Who is it? It's rad.
The firewall's encrypted. Damn it! I need more time.
There we go. Again?
The firewall's encrypted. Damn it! I need more time.
We're in.
We did it.
Good now?
Computers. The last time we did this course, my computer just turned off 3 times in the middle of it. So a little bit of audio is a lot better than me just going away. All right. Yeah. So the one piece I wanted to show on this was kind of just the power of the different conditions that they have. So you wouldn't in real life run this condition because it doesn't make any sense, right? But if you did want to exclude selection arguments, or maybe you want to exclude a username or something like that, you could just do the ones you want to see and not the ones you want to filter out. So this changes our query from being, both of these things that net or net one have to exist and user or local group have to exist. You could just put and not, and then, it'll put that not in there and negate the command line argument. So just a way to kind of show how you can use the different logical pieces of the conditions. Does that make sense? I'm worried that I'm going too fast. I know it's a lot of stuff all at once. Is this all kind of making sense?
There's Mud. Oh, we got a question.
No question.
Okay. Never mind. We're good.
Sweet. Okay.
Continue.
Alrighty. Yeah. So the next one up is going to be encoded PowerShell execution. So in that one, again, looking for some kind of execution, right? So I'm just gonna leave it with this process creation in the windows, and we'll get into the actual logic itself. I'm just gonna leave these filters the way they are because I don't want to change them. The one thing, again, like I said, this is not the best way to test things in real time because YAML cares about spaces and tabs and all that. So if I did this one backspace, oh, look at that. Sync converter accounts for that. It used to not do that, where if you had a space in the wrong spot, it would just fail because it's not a valid YAML file. But I'm just going to leave these as they are. So in this one, we're looking for, again, the, what are we looking for? I forgot. Encoded PowerShell commands. That's what we're looking for. Encoded execution of PowerShell commands. So our selection image is going to be what? PowerShell.exe, right? Maybe pwsh.exe, maybe, I don't remember what the Windows terminal image name is, but could maybe be something like that too, right? Any kind of image, any kind of process that is going to run PowerShell, right? So that's probably going to come from PowerShell, right? And then our selection arguments, there are a few different ways that you could encode a PowerShell command, or some different flags that you could use to encode a PowerShell commands. We have them just kind of listed out here in the hints. So command line arguments like -E and C. Look for -encoded command, or look for -E, and I'll put a space. I'll actually put a space after E and C as well. So this one again, we're just looking for the image of either PowerShell or PWSH, and then these different command line values that we're seeing, right? One piece on this, I'm going to have you guys do the next two on your own, but the one piece on this I did want to point out is, you see, if you have it with these dashes underneath, it's going to implicitly do an OR, right? So this is looking for either PowerShell.exe or PWSH.exe. If you wanted it to be all of these things, you could throw on another modifier of all, which is looking for the image of PowerShell and the image of PWSH, which wouldn't work, right? Because you're not going to have two images for one process. Yeah, you're not going to have two images for one process execution. So if you have it with this colon and then underneath it with the dashes, it's going to be an OR. If you have it I'll just do it like this. Copy. Fix the spacing. There we go. So if you had it without the dash, it's going to throw it in there. Change this to parent image. Parent image is evil.exe. This to all of selection. So we made this new filter of parent process, right? So we're looking if it has a parent process or parent image that ends with evil.exe, right? Or you could, maybe this is WinWord, right? Word.exe, just like we were talking about with the experience slide. This is looking for if a parent image of WinWord, which is Windows, opens an image of PowerShell, which then runs these encoded commands and kind of builds on top of each other like that. But if you have it just the one way, like this with the colon space and then explicitly one thing, is just going to give you an and. So if you have multiple pieces you want it to hit, you're going to need to have them broken down with the dashes and then change that modifier to all at the end of it. If you want it implicitly to be an and. Does that make sense? Again, all the modifiers and things like that, it's all inside of this specification document. It's really, like I said, there is way more. There's like some logic to put into it, some time, CIDR, you can do regex, you can do encoding, all kinds of different stuff in there. But truly the main ones that I see are images, parent processes, ends with, contains, and all. Like those are really the ones that I see pretty much all the time. All right. Then for that one, we're going to switch over to exercise 4, which is the cert util download abuse. Cert util is another living off the land binary that you can utilize to download files. Attackers really like it, I think because it's not PowerShell.exe, so just utilizing something else that maybe attacker or defenders won't see. So you guys go ahead and take a few minutes and try to fill this one out. Again, it's got the answers at the bottom. We've got hints up here, and if you have any questions, let me know. Take a couple minutes for this one.
No, I haven't used this, but you I haven't this. Yeah.
Peacock hit me with my trigger of index equals star. God, that drives me insane. We had on the threat hunting team I was on, you could go into Splunk and put you could basically exclude people from running different commands. So I put in there index equals star as an excluded command, so it would not run when people would go to run it, because it just drives me insane.
Who would do such a thing?
Say, is Trey in there? You better not show his face in this thing.
No, but Peacock is.
Yeah. Well, it's the lab environment. You can do whatever you want, but man, when people would do that in production, it sucks. Be like, why is everyone's search not working? Oh, because we're doing index equals star, earliest equals 0 with a bunch of wildcards. All right. Anybody get through the cert util one, or have any, have anything that they want to show? Anyone run into any issues?
Doesn't look like it.
I think we're good.
So for the excuse me, for the cert util one, again, more of just kind of the same. All of these are, I think all of these are process creation. I don't think we dive into any of the other categories until the other kind of walk through the guided hunt. But in this one, again, we're looking for the image of certutil.exe and some of our command line arguments for some common arguments that an adversary or anybody, I guess, that is using certutil would use to download some files, right? So URL cache, split, HTTP, HTTPS, good ways to indicate the downloading of a file. Another one on here that the cert util I think is like another rule that you could write to detect this as kind of in the same vein. So if this is looking for cert util download abuse, that means that it's probably connecting to something, right? So we could change this rule. Obviously, you have to change the description and title, everything else, but we could change this rule category to look for network connections instead. So if we're looking for category of network connection, now this is changing kind of what we're looking for, right? So we're not looking for command line arguments. Now we're just looking for the process to either to be change the condition. So now we're looking for just the image of cert util making a network connection. So the way again that you can take Sigma rules that you're seeing, put the sysmon on there. So I just put the sysmon pipeline on there. What that's going to do is look at the category and product and then give you the event ID or the event code. So looking at taking this, process creation rule, so our event ID is 1 because that's what sysmon process creation is, and the image of certutil.exe would be like, okay, that's a great rule if we're logging this command argument, but maybe we're getting a ton of hits on this. It's not a really great detection. We need to change it a little bit. It's really, again, just as simple as network connection. And then that changes our 3 to a 1, our image to certutil.exe. And now we have another rule that we can deploy, right? And then if you had, some call a selection user. So then if you have username contains, jabroni or whatever, you can give it selection, all of selection. Why are you yelling at me? Oh, it's because the stupid auto double quotes. So in this one, we're looking for, a specific user jabroni that's running this, that's making a network connection off of it, or maybe we want selection process and not selection user, because we know that this jabroni is running certutil to the internet all the time. We're tired of seeing these alerts, whatever it is. You could change that again to a computer username, IP address, whatever fields exist in your logs are what you can set it to. And then the last one that we'll go over, was everyone able to get something kind of like the process creation one I had up there before? Does that make sense how you get from just this idea of what to look for, then mapping it to fields, mapping it to your fields, thinking of what those values would be, and then just kind of writing it down. That all, again, it all kind of makes sense. It all tracks. Okay. Take that as a yes. And then the last one that we'll do with the skeleton rules is the scheduled task creation. So again, it's going to be a process creation event on Windows. So we'll do process creation Windows. And then actually I'll give you guys a couple minutes to kind of go through this one. And then again, I'll just kind of walk through the guided hunt piece, and then that'd be about it.
You've been watching Discord, Tyler?
Some of them.
Say they're liking what they're seeing, my dude.
Oh, good. Yeah, it's he said it's hopefully it's not too much or going over it too fast. Sigma is a really powerful tool that is a great detection resource. I absolutely love it. It's been, like I said, fascination of mine for a while. Before I came to Scythe, I was never able to really use Sigma rules because I didn't understand how it worked. And one of the first projects I did when I came to Scythe was to understand Sigma so we could better kind of give customers and clients and things like that a way that they could take these detections we're making to whatever their seam is. And it's been really powerful. It's been really great. So hopefully you guys like it and kind of see the power and can put this into your life. Then we had, again, when I was on the threat hunting team, we would deploy to different customers or different organizations for instant response or targeted threat hunting or whatever it was. We had our own toolkit which had Splunk on it, but sometimes we weren't able to get their logs into our kit if we were doing an incident response or something like that, because the logs already exist. They already happened on their seam or in their EDR or whatever it is. So we had more than once we'd have to go to a shop that used Elastic, Kibana, or use ArcSight, or what's the terrible one? I can't think of what it's called. But anyway, we would have to go and essentially relearn their tool. While they're all pretty similar, they are different. And when you're on a mission trying to find adversarial behavior, you don't want to spend the first couple days trying to figure out how the tool works, right? So using something like Sigma rules would have made it a lot easier to just convert our rule to whatever seam they were working in, and then running it that way. And you can do automated conversions and automated rule sets and things like that. It super powerful, huge time saver. And then the one other thing I did want to hit on this, and I forgot to say it in the beginning, you can also, instead of making these rules that I'm talking about, right, you can go to Sigma HQ's GitHub again, and if you're not sure where to start, you can just go on their thing and look for scheduled task creation, maybe. And then we've got a bunch of rules for scheduled task creation, right? We see some process creations here. We see looking in the Windows security logs, a file event. This is a really good one. I'm only going to talk about this for 2 seconds because this is a whole nother tangent. But they're, for our defenders out here, for detectors, detection engineers, threat hunters, you can have state-based changes or just looking at process creation. So looking at process creation is a lot of just looking for keywords, right? So if we have our rule here, let me just put one in here so I can show you what I'm talking about. Come on. So here, right, we're really just keyword searching on scheduled tasks and this command line argument, right? If an adversary changed, if right before they ran this command, maybe they took scheduled task.exe and they renamed it to, good.exe, whatever it is. If they rename it, your image is going to be different, right? If you base 64 encode this command line argument, this detection is not going to hit because it doesn't exactly match what it is. Keyword-based detections are not great because you can easily overcome them, right? So by focusing on state-based detections instead of these keyword detections, you're going to have a lot higher of a fidelity of a search. And an example of that is this file creation here. Whenever you create a scheduled task, it writes a file to one of these 3 directories. It has to. There's no way around it. Doesn't matter if you base64 encode it, you rename it, you do it with PowerShell command line, a BOF, just a beacon object file. It doesn't matter. You can even write out a scheduled task as a file, download it to your machine, put it in this directory. It'll register your scheduled task. So this is a much better rule instead of looking at process creation like we're looking for in this rule here. Instead of looking for process creation that has these image names, we can change it to look for the file name or the file being created inside of these tasks directories, right? So there's more than one way, kind of the same way that we changed our rule of process creation to network connection when looking at the cert util downloads. There's multiple ways you can kind of write a Sigma rule for one event, right? And if you are able to write it for a state-based detection such as this, something that has to happen, it's a much better rule. Yeah, so that's really what you're looking for, but that's for a different talk. That's all right. How you guys doing with this one?
Anybody having issues? Anybody done? Ready to move forward? No complaints, no concerns over here?
All right. All righty. And then we got some, I guess I'll re-show son of a gun. Make sure my screen is still sharing. I got like 9 different SIG converter windows. So I'm like, which one is the right one? I'm just going to do my whole screen and then we'll just see what happens. So yeah, I'm just going to take the answers. And the answer piece, if you guys have gone down to it, it's just the log source and the condition. The other stuff, for this kind of skeleton key example doesn't really matter, right? Like the references and all that. It's just to kind of have you guys going through thinking of what fields match what and, kind of walking through it that way. We have some bonus ones down there at the bottom. Not gonna go over some of these now. We actually kind of already talked about some of these, but just different ways that you can enhance your rules, right? You don't have to do it now, but if you are interested in this, I would recommend trying out some of these ones. So like looking for ipconfig/all kind of from the beginning, or the ones that I think are really a lot better are when you modify the rules to now include parent processes or file locations or excluding different things that you see in your environment. We really need a live scene, that has a lot more data to kind of do the exclusions and see how that works in real time. But yeah, I recommend if you have a lab or have access to a SIEM, kind of mess around with these and make them work for you in your environment. So kind of last call on this prac app. Anybody got any questions or anything you want to go over, or anybody have anything that they found or want to share or anything?
You guys good over there?
That's probably finding it and searching. Anything up in search.
Any question about it or just still working? So it looks like they might be having difficulties.
Oh, with the ARC site, that's
What
the
you
one
got?
that was
What you
terrible.
wanna do?
Yeah, what's up?
So if I take that, saying that I've got everything typed in,
They can't see what you're saying.
my query doesn't return anything.
Oh, yeah. So that's what I was hitting on in the beginning. I think only the first 2 actually exist in this
That
in
makes
the
sense.
SIEM. I didn't have it. I was going to. I just ran out of time, to be honest.
That's that was a lot.
Yeah, sorry. I might have skipped over that in the beginning. All the stuff in the second one though just exists inside of there. Yeah. So sorry on that. Okay. And then so I'll switch over to the other manual, just the workshop manual markdown file. So this is the one that's going to utilize the bots data, and all of these will return something. Let me just replay again. So again, you can either use the bots.splunk.com, which is what I would recommend, because it's newer, it's updated, it has dark mode. The SAM class is great. It's been up for almost 9 years now. This person keeps paying for it, and it's up. So you can use that one too if you want. You don't have to register for an account. It's just student one, and that'll log you in. I'll say, let's go into play again. I'm going to do it from Splunk, but again, you guys can do it from wherever you want, or from bots.splunk. On there, we're going to do the website defacement. The ransomware one did not get through. It's a work in progress. And then it gives us our server here, and then our creds. Oh, I already logged me in. Cool. So again, the BOTS is an acronym for Boss of the SOC. It's a challenge that Splunk made. They put it out at their .conf, which is the Splunk conference. They do it every year. The first 3, bots 1, 2, and 3, are all available on GitHub. You can download them and put them on your own lab and things like that. You can even run it as a capture the flag. So the point of bots, of Boss of the SOC, is they have questions associated with it, right? It's a defensive capture the flag that teams are up against each other trying to win. So essentially what I did is take this scenario and the questions and use it as kind of a guide to walk you through how you would identify this activity using Sigma rules that you then translate and deploy on there. So this does have real data, or real, right? It has data in there, lots of data. I would recommend you go to the date range and you go between, and you set this to August 9th, 2016 to August 11th, because this data should exist on the 10th. So just give it a day in either direction, right? Have that, and then all of this data is hosted inside of index equals bots of v1. If you don't specify that, you're gonna have a bad time. And then, so in there, the kind of just the attack scenario is this fictitious APT called Poison Ivy, has targeted Wayne Enterprises public-facing web server, which is running Joomla, which is their their server that hosts their content media server. I think something like that is what it stands for, CMS. Anyway, so it's essentially, it's just walk you through a website defacement attack. So up first, the key systems that are affected. Again, this is kind of a white box kind of scenario where we're just walking through something that we already know, right? Like this is like the final instant response or something like that. And then it goes into the source types. I put this up here because, again, this has a lot of data, not just sysmon and security logs. So when you're looking for website connections or network connections or form data, or different, URIs, different pieces like that, you're going to have to utilize these different sources and source types. You don't have to specify it, but again, it just is going to make it run slower. And then it's just broken down into some of these sysmon event codes that we had pointed out before, again, just to make it faster. In real life, you're going to include, or you should hopefully include your source type, your index, your event codes, host name, maybe different pieces like that, because when you're looking at more than a little bit of data, and a lot of people are looking at it, it's like pretty near impossible to find anything if you're not being a little more specific with it. And then, yeah, just kind of how to use this, right? Read the rule, translate the rule. Ideally, I would like you guys to write your own rules, but it's kind of up to you guys. Again, this is just kind of to walk you through what's happening, explain how these rules work, some of the key fields that you're looking at, and what this activity means. So we're definitely not going to have enough time to go through all of them. So I'll just talk about the first one, and then if you guys want to go through the other ones on your own, that'll pretty much bring us to the end. So the first one up, we know that the attacker utilized some kind of web vulnerability scanner. We know that they utilize Acunetics, I don't know how to pronounce it, but they utilize Acunetics to run a vulnerability scan against our web server, right? So what are we before we even get to the logic itself? That's not true. We'll get into the rule. So you can see that the rule, the log source, if we go down to the detection piece, our log source is already different, right? We're no longer working with Windows. We're looking just for web, and we're no longer looking for like process creation or network connections or anything like that. We're looking for proxy because that's what logs these should exist in, right? So it's a little bit different, which again is why you really want to refer to the Sigma specifications, this taxonomy, because it's really going to help you out to identify these different pieces, at least when you're first getting started. So this one, I'll take this rule here. I will go to sigconverter.io. And we see that our rule here, again, looking for web proxy information, is looking just for the user agent to contain Acunetics, right? Nothing super crazy here. So we're going to refer back to the documentation because I don't remember exactly what I had in here. And we'll do source type equals stream HTTP because we're looking for that HTTP or that web proxy data, right? That's where it would exist in our logs. So kind of taking the assumption that as a Defender, you've mapped out your log sources to the events that it's correlated with it. That's a big piece of detection engineering, knowing where your logs exist or don't exist, where you have gaps in. But anyway, so this one we know that it should be inside of that stream HTTP data, and we're looking for just that user agent string to contain Acunetics. We'll just run a search on that without any of the tables or sorting or anything like that and see what comes back. So we get some stuff back. Looking through, again, it's very difficult to read and kind of figure out what's happening when you have just these raw logs over here, right? So you can click on, you can click on these interesting fields over here on the left to kind of break down different pieces of it. But in this one, right, you've been a Defender for a while. You know what fields you want to see. So we'll use a table to then break down the time, source, destination, path, and user agent string. And we'll see here that the user agent string is going to this destination IP of this local host, this 192.168, which we know up here is our web server's internal IP address, right? Our compromised web server. It's going to the root of it, and it's just scanning it, right? We see this Acunetics security test scan that's going through and scanning what's happening. Also saw before when I was looking at interesting fields that had site as an example, so that'll give you the URL or the the domain name of what is being scanned. So table is going to list out all of these fields. You can also include the fields that you want in your Sigma query or in your Sigma rule. We didn't for this workshop just because it just felt like a little more added onto it with just 2 hours. But you can specify what fields you want them to pull out in your rule, which is very useful as well. So you have the table, which is going to list out these individual fields all the way down. But if you had a ton of them, like when you guys get to the password, to the brute forcing, you can do a stats, which I want to do a stats values on HTTP user agent by site. So what this is going to do is this just going to logically group together what you're seeing, right? So of these HTTP user agents, if they all are going for the same site or destination IP or any other field that matches, it'll just group it like this, which makes it a lot easier to identify what's happening, right? You can do stats values, you can do a stats count by HTTP user agent, which will give you a number of how many times those user agent strings are used. All of these are unique because they're one, but some different ways, if you're familiar with Splunk, to just kind of group and stack this data together. But all that, you can copy that. Should reflect pretty much what your translated rule is. The good piece with this, and I'll leave you guys to it when you kind of on your own time, is when you get lower into some more of these attacks, it's not going to be as clear cut exactly what's happening because there is a ton of data in here. So like if I just do this form data one here and I take out, I don't want to do a stats count by IP. I just want to see all the data itself. So 413 events, that's a lot more data, right? There's a lot more in there. So you can think in this one of going back and modifying your Sigma rule, maybe putting some exclusions in there, things that you know are good, or doing something like stats values, form data by, see a good one over here. We'll do that by HTTP user agent. So this one even breaks down. So now we have our two different user agents. We're looking in our form data for password with asterisks on either side of it. That again comes from that contains of putting it on either one. So we're looking for a post request going to our Joomla administrator URI with some kind of password. So someone attempting to brute force login or attempting to log into our Joomla server, right? When we look on here a little more, we can break down with our stats values these two different fields of the user agent and the form data itself. Seeing something like Python URL lib as the user agent string, probably pretty odd, right? Having Python be the user agent string and not like Mozilla, Chrome, whatever the iOS one is, Macintosh, different pieces like that. Like what you see up here is much more normal. This is abnormal, right? This is very, very strange. So it definitely seems like some kind of automated attempt, which if you look at the times, it'll probably agree with you here. You can see the name admin, and then if you go here, you can see the passwords that they're using all the way down. Steelers, you're never getting in with that. I got Gandalf, got some bad words in here. All kinds of different stuff. You see tons and tons of information in here all the way down. But what is interesting in this one, this would be, I think, maybe my last point, and then turn it back over to you guys, is why do you think we see all of these requests from Python URL lib, right? I'm not going to do a count on it, but we can see that there's a ton, right? And then we see one form data with this username and password from a Mozilla kind of standard looking string.
So we got one person saying looks like a brute force that could potentially have ended with hey, well, they found what they needed, right?
That's exactly right.
So that was a successful login.
That is exactly right. So if you see, that is a great job, whoever said that. If you see, and there's another query further down that goes over the same. Why is it giving me all this now? I was already logged in. Come on. There's another query later on in the lab that kind of shows the same thing on that from two different IP addresses. But that's exactly right. If you see a ton of stuff from one, like if you see 1,000 failed logon attempts and then one successful logon attempt, that's probably the right one, right? They probably found out what they were looking for. You can assume that they're in, right? So yeah, great job, whoever said that. If I was there in real life, I'd give you a pin or something. Yeah, but with that takes us pretty much all the way through it. Again, this manual is really made for you guys to go through it on your own. I think it describes what we're looking for pretty well, but you can mess around with the data, right? You can change how it's presented. You can change these rules. You can take these rules back with you. They're all sourced in rules, and then of course not everyone's here, so you can take the rules exactly from there and not outside the manual if you want to. Yeah, any questions or comments or anything you guys have for me?
Yeah. These detections should be in your honeypot if they're not already.
These detections should be in your honeypot or detections at home, at work, if it's not already.
Yeah, for sure. A lot of these ones, especially on the poison ivy scenario of the website defacement, they're great. Anything you have publicly facing the internet, probably some good ideas to have. Maybe not these exact queries because they're kind of tailored to this, but something pretty similar to it. And if anyone's hosted anything live on the internet, within a couple seconds, you'll be getting some scans. You'll be seeing some pretty interesting data in there. It's yeah. We hosted a site on Python Anywhere, and I think within an hour we had like 30,000 attempts to hit it. So yeah, anything got on the internet is going to be looked at immediately.
Any last comments, questions, concerns for speaker? Everybody all good? All good here, my dude. Good job tonight. Appreciate your time.
Yeah, thanks, guys. Yeah, but say thanks. Hopefully this went okay. Everybody got something out of it. Maybe. I'll leave the GitHub repo is going to stay open. I got the slides in there and stuff. And if anybody has any questions or wants to chat or anything else, feel free to hit me up. Hopefully see you guys down in May at B-Side Tampa.
Sounds good, my dude. Thanks for your time.
Thanks, guys. See you later.
And Chris, you can take us out.
And we're good. Yeah.
It's time to say